Hey, welcome back. Today we're going to be talking about how to solve rotational inertia problems or moment of inertia problems with combination style shapes. But first, I want to show you a quick clip of a ice skater. So I do want you to remember this. Notice her arms are extended at the beginning of this. Towards the middle, she brings her arms and legs in, which means that she speeds up. She gets faster, and we want to start to think about why that is. So why does she rotate faster when her arms and legs are tucked in and slower when her arms and legs are put out? And the answer is mostly because she has a different moment of inertia. She has a different I value in both cases. And you can actually calculate different I values in both cases. And it feeds into something you probably haven't gotten into yet in your course of physics or AP physics, and that's of angular momentum, which will be a later topic, but this is a stepping stone to be able to understand that. And we're going to have this be like a cylinder, and this is going to be like a cylinder plus two rods. In other words, we can approximate her body in the first case, in the top example, when she has her arms and legs tucked in, as if she is a cylinder, and approximate her body with her arms stretched out as a cylinder with two rods. So let's do the math for both of those and see that we're actually going to have different values. I do want you to anticipate which would have the greater moment of inertia, the greater I value. Which do you think is going to have the greater I value? And think about what you just saw with the other skater who was going faster when her arms and legs were pulled in towards the axis of rotation, and slower when her arms and legs were put out towards the outside of the axis of rotation. Alright, and so if you take a look at this, we've got a I value for her as a cylinder as this value right here. Now, if we're going to do this for the second scenario, it's more complex. So we have to treat her body as a cylinder and her arms as two rods. Alright, and notice because there are two of these arms, we're going to go ahead and multiply that 2 in. So we'll treat that fraction as if it's a 2/3 fraction here. And we're ready to go ahead and plug in some numbers. Okay, and so all we need to do, whenever we have a system that has multiple simple objects put together, is we need to just simply add up the moment of inertia, the I value for the different objects, into a more complex shape. So the cylinder with the two rods attached is a more complex shape, made up of just simple shapes, you could say. So if you finish out the problem here, it looks like this is going to be our total moment of inertia here for the second scenario when her arms are extended. Now check this out. Compare this when her arms are in versus when her arms are extended. And this is going to be a key value here. You can think of the moment of inertia. If it's going to be greater, we'll actually slow her down more. So that's how you go about calculating the moment of inertia of a simple shape and the moment of inertia of a more complex shape like we have in scenario 2. Hopefully this has been helpful. If you have any questions or comments down below, please let me know. And I hope you all have a great day. Take care.